Okay, so looking at vocab real quick. We are starting algebra, like I said. Algebra, of course, mathematical language of symbols, including variables. What other subject have you heard the word variable? Science. Okay, so in science, a variable is something that what?
It's being changed.
Okay, so it's something that can change. So in math, it's exactly the same. A variable is something that can change. We're not going to be using variables today. We'll start using them tomorrow. But a variable is typically represented with a letter, and it stands for a number. A lot of times it's the unknown. All right? Actually, add that to that definition right there. Right here, variable, we're going to write the word unknown. Because a variable will represent what we don't know. We're going to be dealing with expressions today and this week. There are two words you'll hear as we move through algebra, and that's expression and equation. When you hear the word equation, what does that first part remind you of? Equal. So with equations, you will actually use equal signs. When we're talking about expressions, there are no equal signs. So that was one of the things I was going to tell you. Today, what we're doing, tomorrow, the rest of this week, there are no equal signs on any of the work you're doing. Okay? No equal signs. We'll use equal signs when we get to equations. Of course, evaluating means to solve, but when we're talking about algebra, when we evaluate something, we're also going to be substituting numbers for our variables. Okay? A term. If I had the expression 1 plus 4, 1 and 4 are your terms. Okay? So the same thing will be with algebra. If I have the expression x plus 5, what are my terms? X and 5. It's whatever you're dealing with in your expression that's separated by an operation sign. Okay? So those are terms. When we talk about like terms, it simply means that. They are alike. It's the same variable, okay, to the same power. Meaning like if you have x and x squared, those are not like terms. But if I had 2x plus 3x, I could combine those and get 5x. Okay? So, yes, so like terms we can combine. Crazy thing is, right now you've always been dealing with like terms. Whole numbers are like terms. They're constants, which is going to be another one of our vocabulary words. In science, you guys talk about the control or the control group. That's what stays the same. It doesn't change. In math, we're going to call that a constant. Okay? So if you had x plus 5, what's your variable? X. And what's your constant? 5. 5 doesn't change no matter what. Okay? X could change, and we'll get to figuring all that out. Okay? Right now, we're only going to be dealing with numeric expressions. Tomorrow we'll add variables to it, and they'll become algebraic expressions. So numeric expressions are simply what we have done all year long, and we are also going to be using order of operations. Okay? Let me give you a reminder. When you're dealing with order of operations, you kind of think of it like hopscotch. We have our parentheses or grouping, whichever one you want to use, exponents, then we multiply, divide. Multiplication and division are together. Remember, they're partners. And then addition and subtraction are partners. And these you will solve, whatever you get to first, left to right. So, yes. So there may be times where we divide before we multiply. There may be times where we subtract before we add. Yes?
Coach, my math teacher last year, he said it as, please excuse my dear outside.
And that's what we said earlier this year. That's what we talked about, and that's why we have that poster on the back wall. Yes, remember, we've done this before this year. Okay, so here we go. Number 1. What is the first thing we're going to solve? Parentheses, right? Guys, you must show me every step. If you don't show me every step, and it's on a test, I'm going to take off points, and here's why. Here's why. When we get to solving 1- and 2-step algebraic equations, you have to show your steps or you're going to mess up. So here we go. We're going to bring everything down except what's in our parentheses, and we're going to go ahead and solve that. What is 15 minus 7?
8.
Times 2. minus 9. So, now what can I solve next? Division. I don't do the multiplication first because remember, they're partners. It's whatever you come to first, left to right. So 64 divided by 8 is what?
8.
Times 2 minus 9. What is 8 times 2?
16.
Minus 9 is 7. Guys, you must show every step. I understand some of this you could probably do multiple at a time and do in your head, but you have to show every step. When you get done, your problem should look like an upside-down pyramid.
Or a pizza.
Or a pizza slice, yep. Okay, here we go. Looking at this one, what are we going to solve first?
Parentheses.
Parentheses. Now, remember, when you're in the parentheses, your order of operations starts over again. So once you're inside the parentheses, then what are we going to solve?
Exponents.
Exponents. So now we have 13 plus, I'm going to put my parentheses. What is 4 to the third power?
No.
Not quite.
30 times 4 times 4. 64.
Very good. Thank you, Drew. 64. Because you remember, 4 to the third power is the same thing as 4 times 4 times 4. This is 16. 16 times 4 would give us 64. So now, what is 64 divided by 2? 32. See how I'm bringing everything else down that I'm not solving? Now looking at this, what do I solve next? 32 times 5. Multiplication, division comes before addition, subtraction. So we have 13 plus, what is 32 times 5?
165.
Say it again.
165.
Not quite. What's 5 times 2?
110.
160. Okay. So, now we can add and subtract. So, 173 minus 17, and that would give us
156.
very good. 156. I know that's kind of squeezed in there. All right. So, now it's not only important to know how to solve or evaluate expressions, we got to know how to write them. So basically what you're doing is we're translating words into numbers, okay? Again, algebra is a separate mathematical language, so we're taking that language and we're transferring it into numbers. So here we go. An art supply store sells posters for $9 and picture frames for $15 each. Write an expression for the total cost of 6 posters and 6 frames. So what we've got to know, they're $9 each, $15 each, and you're buying 6 posters and 6 frames. So what's going to be my first step?
6 times 9.
Absolutely. So we're going to go ahead and say we're buying 9, we're buying 6 posters, so 6 times 9. That represents our posters, right?
Yes.
Okay, so what are we going to do to represent our frames?
4 times 15. Or 6 times 15.
6 times 15. Now, what am I going to do?
Addition sign in the middle.
I'm going to add those together. Do I need parentheses around these?
No, ma'am.
Could I put them?
Yes.
If I want to put them just for organization, it'll work. But it would not change the order in which you solved it because of our order of operations. We would always multiply before we add. So it wouldn't change your answer. But if you want to put the parentheses, you can.
Can you multiply either one first?
Yeah, it wouldn't matter. You could put 6 times 15 first or 15 times 6, yeah, because of the, yeah, absolutely. Okay, so what would be 54, 6 times 9? Sorry, I almost said it.
54.
Okay, and then 6 times 15?
90.
So our total would be 144. Now, is there another way we could write this expression?
Probably, yeah. Order of operations. Yeah.
What could we do?
You could put stuff right to the back and back to the front. Could you do addition and then work it out from there?
Could I do what? So what do you mean? Find out how much one poster would cost? Maybe? Alright, let's look at this. I'm going to go with what Ava just said. Could I say one poster framed is going to cost me 9 plus 15. Right?
Yeah.
Okay? But how many of these combos am I buying?
15.
So if I look at this, and I'm buying 6, because I'm buying 6 posters and 6 frames. Look what happens. Can I add them together first and then multiply by 6?
Yes.
Let's try it. So 15 plus 9 is what? 24?
Yes.
Yeah, right? Yeah, 24. Okay, so now, if I look at this, remember we said parentheses means to multiply. Very good. So what is 6 times 24? 6 times 4 is 24, so 4, carry my 2, that's 12. Oh, look what happens.
How do you know that? That confused me so much. I thought you got a different answer because you wrote both your 4s differently.
Oh, I'm sorry. I do that sometimes. I change them up. I don't know why.
How do you know to multiply the 6?
Well, basically what I'm going back and looking here is saying, okay, I'm trying to think of it logically. Like I know I'm buying 6 posters and 6 frames. So if I buy a poster and frame, that's one set. So I'm going to add that set together, but I'm buying 6 sets. So I could multiply by 6 on what one set would cost. But either way would work, guys. Do you remember back in 5th grade when you started learning properties?
Yeah.
Like the commutative property?
Yeah.
Does anybody recognize what this would be?
Yeah.
Thingy? No.
Oh, they're
6
all.
times 9 and 6 times 15.
No, they're all.
When you pass something out,
You're handing it out. You're handing it
You're
out.
getting less.
starts with a D.
You're disposing.
Not disposing.
Dividing. Decreasing. Diamond.
Distributing. So this is actually an example of what we would call the distributive property. Anything I'm multiplying by the outside, I'm multiplying to everything. 6 times 9 plus 6 times 15. These are the same exact thing. Okay? Well, we'll get to more of distributive property as we move through algebra, but I just want to show you that this represents the same thing. Anything on the outside of the parentheses is multiplied by everything on the inside. Okay? Yes, anything on the outside is multiplied by everything on the inside. Okay, let's look on the back real quick. No, you don't have, either way would work. Okay, back to me, guys. I know number 1 you could probably do in your head. You must show your steps, and you must not use what?
Equal sign.
Equal sign. No equal sign yet. These are all expressions. So you can say no equal sign. Okay, so first step, am I going to add or subtract?
Subtract.
I'm going to subtract left to right, whatever you get to first. So what is 7 minus 6? Plus 5, and that would give us, there we go. If you added first, you would have gotten a negative answer, which would be wrong. Okay? All right, let's look at number 2 real quick. This time, what am I going to do first? Add. So what's 31 plus 19? 50 minus 8, and that would give us 42. Again, guys, I know some of these are super short and simple. You've got to show every step.
So what if you had 2 exponents?
Number 16. Let's look at it. Here we go. It is okay to do the same operation. Like if you have multiple of the same operation, it's okay to do them at the same time. So if we look at this, and what are we going to solve first?
5 times or 5 to the
Exponents. So we have 2 examples of exponents, so I can do both of those at the same time. So this would be 100 divided by, what's 5 to the second power? 25 times 64. Now, what am I going to solve first?
You're going to solve your 100
Division, because I'm getting to division first, left to right. Okay, so 100 divided by 25 is 4 times 64. And what would that give us?
1,600.
Not quite. 4 times 4 is 16.
Carry the 1, 25.
What did I do?
Okay, so when you have
24.
the same operation, like if you have 2 times where you're multiplying, and then maybe an addition sign in the middle, look at number 9. We'll do one more together. Okay, if you look at number 9, okay, so what am I going to solve first here?
13 times 4.
Okay, so that would give us
52.
52. Okay, can I go ahead and do 72 divided by 8?
Yes.
Yes. What is that?
That is
9. So 52 minus 9 gives us
41.
No, 43.
43. Very good. Okay. Yes. Which one? I didn't. I did 72 divided by 8. Then I subtracted. Yep. All right, let me stop this real quick.
Bye, everything.